And something that I find really interesting is a lot of his art doesn't make sense, or it's inaccurate. A lot of his art contains like grotesque misrepresentations. You'll need your 3.2 today. We're going to skip around and talk a bunch of evolution concepts. The reason his art is so wacky sometimes, it has so many errors sometimes, is because Alberto Siba made art during what I think was the most interesting moment in European history. And I know that we learn history because of war and because of conflict in religion and stuff. And of course that's important, but I'm a scientist and I kind of feel like the most interesting time for the things that I care about was when Alberto Siba was making these wacky drawings. We got to talk about ships. I think all of you know that Europe's over here, and the Europeans, especially these Europeans right here, would send ships to explore the rest of the world. When we made ships that were good enough, we started mapping further and further. And I think everybody knows that investors, people with a lot of money, would pay the captain, they would hire the crew, they would load the ship with food and ammunition and ropes and stuff. And they would say, go over there and see what you find, and we'll put some stuff on a map and we'll improve the map, so to speak. Something that you gotta realize is it takes a lot of junk back in the 1600s to go sail around the world for a while. So if I got a crew of this many people that are gonna be living on this ship for like 4, 5, 6 years, that's a whole lot of top ramen or something. You gotta figure out how to feed all these humans. Like, when they need to cook, they're gonna have like fires on their boat to cook food. So they gotta take firewood or coal. They gotta take like lots and 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 lots of water and booze. They gotta take like rolls of fabric to like make clothing and stuff. Think about it, they gotta take like all kinds of wacky gunpowder and like metalworking tools, maybe like a blacksmith on the boat. And then when they use up all that stuff, their boat is empty, so they might as well do something with that boat coming home. So when rich people would pay for their crew to be provisioned, they would find some loser and be like, yo, you go with them and shoot one of everything and bring it back. Coincidentally, that's what happened to Charles Darwin. Fun fact, Charles Darwin was like a trust fund baby. His parents had a lot of wealth, and Charlie was like, yo, I just want to like sit at home and like fiddle the chicks. And the parents were like, sorry Charlie, you gotta get a real job. And he's like, but I just want to be a player, dog. And they're like, no, you can't have the trust fund. And so they made him go to like priest school. And he was like, boo, being a priest is boring, there's no chicks. So he like dropped out of the seminary after 2 years. And then his parents were like, you gotta do something, Charlie. And he's like, can I just sit at home and drink? And they're like, go be a doctor. And I guess he was like squeamish, and he like fainted when like they taught medicine by like tearing people open. And so he was like in a surgical theater, and they started like cutting into some probably prisoner guy. And like they start like tearing the guts out of this human, and he's like, oh, and he like fainted. And so he had to like drop out of doctor school, and he's like, can I just stay home? The parents were like, no! And so they put him on this ship with all these like burly seamen. P.S. He got bullied the whole time. Like his journals of, I'm glad we can all laugh about this. His journals of the journey of the SS Beagle, is that what it was called? Mm-hmm. The Beagle? Bugle or Beagle?
I think it might be
like the dog.
Beetle.
Whatever, I think it is Beagle like the dog. That sounds kind of right. I think I've heard somebody say the dog thing before. On his journey of whatever the heck it was called, where he like went to the Galapagos and he ended up writing what became the theory of natural selection. On that trip, he had a whole lot of time to shoot stuff because he was afraid to be on the boat because he got beat up every day. He got like really seasick, and so he would like try to come out for fresh air, and then all the like burly seamen would like elbow him, and he'd be like, so he'd like go back to like his little room, and he would like sit in his hammock and throw up. So he lost hella weight. Beagle. But he did the job that he was supposed to do. He shot everything. He knows so much, or he knew so much about life because he had a tremendous collection of life that he was filling for one of his dad's rich friends who sponsored that boat. Charles Darwin was the collector on a ship that was exploring because he couldn't find a real job. So some rich guy did a favor to Charles Darwin's father and hired him to go around the Americas. P.S. Charles Darwin has probably eaten more bird species than any other human ever because he lost so much weight from barfing while crossing the ocean and getting bullied. He never wanted to be on the boat. So they would get like close to shore and he'd be like, okay, I'm going in. And he'd like get a rowboat and he would like row onto land and he would shoot one of everything and he'd be like, oh, this looks neat. And so he would eat all these obscure birds. Apparently he really liked toucans and parrots and like, toward the south of Argentina, he saw these flightless birds called emus.
Really?
Is it the emu or is it the gnu?
It has really big eggs.
It is Australia. So Africa has a giant bird, the ostrich. Australia has a giant bird called the emu, and Argentina has a giant bird called the
Nunu.
Whatever. And so he shot those, and he's like, whoa, that's really neat. And so he shot one and put it in the box, and he's like, I'm gonna kill these. And he like shot a whole bunch of them for food. He's also eaten the most turtles. Apparently turtles are really tasty. You know what's nice about turtles? You can just turn them upside down, and then they survive for like months. So they're really good to take meat to go on a ship.
Aww.
I mean, it's smart though.
That's smart.
It's really smart. You flip them over, they're like, meh, for like a year, and then you can get fresh meat.
That's really smart.
That's why the giant tortoises are gone from all the islands, because the explorers took them all as meat to go. Anyway, look at this wacky guy. Look at this room full of strange things. These were called cabinets of natural curiosities. And rich people would have parties, like rich people do. And they'd call all their rich homies. And they say, powder up your wig. corset and come on over. We're gonna have a hoedown. I just got a shipment of weird life from South America. And everybody would show up and they would all wait. And then like the host or hostess would come out and go, "Hi everybody, welcome to the Americas." And everybody would like walk into these like banquet halls and be like, "Whoa, look at this!" And they would all play with these like poorly preserved specimens with like chunks of flesh falling off and maggots and stuff. Oh, it would smell bad. So there was like special clothing that you would wear that was extra fragrant. A lot of that powder was like to like cover up the smells because people would be like walking through these like rotting shells and stuff. The smells were supposedly really rank. Yeah. Are you waving your pencil?
No, I mean like kind of. Didn't they just like not have like deodorant back then anyway though? Like and very limited showers, like they smell bad
Yeah, but
too.
all those smells were already normal. So if you smell bad and I smell bad, I'm just used to my bad and you're used to your bad. And so when other people come around us, they think that we smell horrible. We go to places that don't use deodorant and go, "You all smell like BO," and they're like, "Yeah, but you smell like deodorant." Like we just have our smells, and so this was a new smell. All the rotting, you'd walk into these rooms and there would be just like weird stuff rotting. And you know, some of these collections were actually like really profoundly important. Today, a couple of institutions around the world have adopted most of these collections. So a lot of the stuff went to Cambridge and a lot of the stuff went to Harvard, actually. And a lot of those collections preserve really well. Like butterflies, you can keep a butterfly in a box for basically forever and they still look beautiful. And so some of the stuff from those collections has rotted and not done very well. Like dead elephants and stuff, that's like a lot of rot. But this wacky dude, Alberto Seba, would like sit and draw his collection. And he was just another rich white guy that paid poor white guys to go take stuff from poor colorful people. Imagine the jumble of ideas at this time. You've got creationism coming from the church. You all know creationism, the idea that God created the earth as it is. You've got this new rising knowledge that there are people with different colored skin in different parts of the planet. And by the way, because they have different colored skin, maybe they could be property and we could sell them. You've got these mysterious species that we only understand from drawings because then they go rotten. So like, that's a sloth, y'all. If I brought you a sloth that died 3 years ago in a box with a note that said it was in the trees, you'd be like, okay, great. And the face had all gotten rotten. And you know, faces shrink when they rot because there's a difference in fat, connective tissue, cartilage, something, faces shrink. So look at how this guy drew the sloth. Like, oh yeah, in the tree, got you.
Hey, but look at the bald one.
I don't know why there's a bald one. Maybe the fur fell off and you thought that. I don't know. This is what I'm telling you. Imagine if this was science, though. Imagine if this was science, though. Imagine if this was actually the state of the art.
He thought that that's what an actual animal looked like?
Yeah. All of you are spoiled on information. No, I'm serious. I'm so happy that you grew up in the internet age, but if you're curious, while you're talking to somebody, you can complete your research before your sentence is done, and you could be like, yeah, you know, sloth, no big deal. And I can turn around and I can be like, boom, sloth. And that's how long it takes you to understand sloth. And you could be like, oh yeah, it's sloth, I got this. I literally, like, that's all it takes. What was that? 8 seconds? back then it's like, yo, there's these things called sloth. They're like, what is that? And somebody's like, you know, they're like that. And you're like, cool, tight. And like, this was science. I'm serious. Consider the jumble of information where science was done by the privileged few based on paintings of millionaires' collection of stuff that was exported and not well preserved from places on the map that were just being drawn. So you're starting to figure out what's on the planet by also mapping the planet. This is neat. Yeah.
Like, would there be like con people that just like, you know, I'm gonna
I would.
mess with these guys and like take like a cat and like, you know, just distort it, like sew 2 heads on it or something.
Doesn't that seem like an obvious opportunity, right? Like, I think that this must have been a fascinating moment. Studying these collections, people wrote books, and they would like sit in rooms of pressed plants and be like, oh, look at this neat pattern. All the orchids are on this part of the map, but all the palm trees are on this part of the map, but all the cactus is on this part of the map, but all the euphorbia are on this part of the map.
Why didn't they just bring like one artist person too who draws them when they die?
I would imagine that they probably did that too, but most of this artwork was not like impressionist, quick 30-minute sketches. Like, I can shoot 500 birds in the time it takes you to paint one. So you probably get more collection by bringing them back. But yeah, there was traveling artists with many of these expeditions too. I don't think that anybody today has the type of curiosity that the average European must have had during this moment. I'm not saying that they were good people or that they did good things, but I think that curiosity is fascinating to me. I study European history as the birth of a science, and I'm blown away. Study goal number
9.
$14. People notice patterns of distribution. People notice that there's like certain types of animals on the different continents. So they're like, oh, we went to this continent and we found a bunch of lizards up in the trees that pinch the branch and have eyes that move independently and they change color. But those are only in the Ethiopian chunk. And then some other ship comes back from Australia and says, oh, we found lizards that have hollow fangs that are venomous, and if they bite you, your skin rots.
Classic Australia.
But those are only in Australia, and somebody else comes back and goes, oh wait, those are also in the Orient. And people go, oh wait, so there are monitor lizards, Varanidae, in Australia and in the Orient? I wonder if they are elsewhere. And so they go to the cabinets of curiosity and they open up all the lizard specimens from South America and from Europe and from North America, and they bang the heads open and they go, huh, no hollow teeth. That's neat. And so people start to write these descriptions of these patterns, and it looks like each of these chunks has discretely unique biodiversity. And each of these chunks has discretely unique plants. So they're called the provinces of vegetation and the realms of animals. 2 different scientists wrote these 2 different books about these different interesting patterns. And this gave rise to a science called biogeography. Oh, I cannot spell. Oh God, I really cannot spell. Once you start to mess up, you really mess up. Biogeography. Mapping patterns of life. Yo.
So on the last slide,
Yeah.
there's like that little circle like underneath
Yeah.
Africa. What is that like? That's the only plants in that one spot.
Yeah. And since then, we have found other clusters of unique plant life. So Indonesia has very unique plant life, and PS California has very unique plant life. There's a few little places that have little pockets of unique independent life. Now we understand this. They're called ecological islands. They're little chunks that are separated from the other biomes around them by different conditions. So you have like a little pocket of chaparral surrounded by desert, and so that'll evolve on its own, even though it's connected to the rest of the land. It has different conditions. So it's like being Australia or Hawaii or whatever. You're just separating from your neighbors. Yeah.
What's California's unique?
Well, we actually have a number of unique habitat types in a really small space. So because of the Sierra Mountains and because of the chaparral region that we live in, we are the most diverse plant community of its size anywhere on Earth, tied with the diversity found in Indonesia. Anyway, back in the day, these scientists were looking and they were like, wow, man, what the heck's going on? They noticed this interesting pattern where there are mammals everywhere in the world that are placental. You all know what a placenta is? It's like the eggshell on a fetus inside of a woman. P.S. Both of my babies were born at home. No, we did not eat their placentas.
No.
What?
But we did bury them underneath trees to fertilize trees. So each of my children has their birth tree on that property where they were born. My girl has a big leaf maple, a native maple, and my boy has a big coast live oak. And those trees thrived on all the iron, I guess, from my baby's flesh shells. Or whatever.
That's a nice way to put it.
Dude, it's weird. It is weird. It is weird. The placenta is gnarly. It's like heavy. It's like a chunk of meat.
I like get the spirituality of like, oh, eat the placenta, but like it makes me want to vomit.
Yeah, I understand
I
the
don't
concept,
get it.
but it did not look appetizing at all.
Oh, were you considering eating it until you actually saw it? You're like, I can't.
I honestly,
do this.
I was not considering eating it. I had actually seen photographs and heard from people who'd eaten it that it's not very tasty.
That's why you decided not to eat it?
It's like money.
I guess we talked about it, but we didn't. Neither of us was into it. I was like, nah, and I was like, nah. And then like I saw it come out of my wife, and I was like, no, no. I mean, it's like
Probably tastes like
it's like a small tri-tip worth of meat. It's a lot of stuff. Yeah.
That's like cannibalism, isn't it?
Kinda. Yes. I mean, eating your fingernails is cannibalism.
Okay, but that's
It's not the whole. It's not the whole human. It's the human eggshell. What?
Doesn't
Not a
like
placenta.
the reason that people eat placenta is because of the same thing that like if you eat human flesh, you use all of it because you're a human. So isn't it like
The idea is that the mom can get a lot of iron back because it is actually a big iron drain to have a child. So that parasite sucks out all of a woman's iron. And so she gets taxed pretty hard. It's like that fetus is filtering her blood to steal all her iron. And then you're just gonna throw that out? And so some women take iron supplements, or you could just eat it again. Yeah.
Almost every mammal on Earth, like, the mothers eat their placentas.
Yeah,
right?
most animals eat placenta. Yeah.
This is kind of off topic, but not really. Is it true that humans have like stripes or like a pattern like a tiger on them? Is that true?
I don't recall that from either of my babies.
And like we can't see them, like humans can't.
What
see
the hell are you talking about?
them. I'll bring you a photo.
You are so tripping.
No, I'm serious.
They have a pattern that you can't see.
Yeah.
That we all know about.
I'll bring it to you tomorrow. I'll bring you. It's like I don't know if it's like a meme on Instagram, but I saw it on Instagram.
You have lost the speaking shell. No more speaking today.
Okay.
Okay.
What? Yeah,
If you can't see it, then anything one
that.
you
I
guys,
you can't see it. Like,
No, no, I wish I was
If you
decided.
guys-
I have invisible polka dots.
I wish I was decided that, buddy.
I thought like tigers.
It's
I
like
don't
one of
know.
those. It's like one of those stories on Instagram. It's like your soulmate has the same.
You're making me dumber and you're encouraging her. Stop. Okay. Okay. Bite me. I'm curious what you're saying. Okay. Okay. Back to this guy. Marsupials are kind of neat. Marsupials are kind of neat. Instead of keeping the baby on the inside,
Wait.
instead of keeping the baby on the inside, the way that humans do it, marsupials will be cruising around, and out of the woman will tumble this little tiny fetus when it's about the size of a grain of rice. And she doesn't even know that she has passed a fetus. It's not attached to her. It just kind of bumbles out. And it has claws that will grab her body hair, and it'll climb up, following the smell of milk, until the marsupial fetus falls into the mom's pouch and starts suckling on one of the nipples there.
So kangaroos.
Yeah.
Do they look like the mom, or are they like weird?
They look like a fetus. They're like bald and their eyes are skinned over, and all that they have that articulates are like hearts and hands. And they just climb her body fur and they fall into the pouch like a kangaroo has a pouch, so do all the marsupials. Can you imagine how exciting it must have been to be the person drawing the crap when Australia's box showed up? And you like go like, hey, wait, there's a pouch, and like, wait, there's a baby. Wait, there's nipples in there. And then you're like looking at all the other stuff in the box, and it's like, oh my God, there's more babies. And like all the mammals coming from Australia have a pouch. And you have to like go check the cabinet for like, what about these South America ones? And like, nope, no pouch. Yeah.
So just really quickly, the placentals are the, so that's going to carry it inside the body.
Yes, in the placenta.
Yeah.
We are placental mammals.
Yeah. And then
All of us
marsupials are
build a
outside.
shell when we are a fetus called a placenta that does nutrient exchange with our mother.
Yeah. But so the marsupials are outside the body.
The marsupials are outside the body. They fall out of the mom like a grain of rice. She doesn't even know. Every week or two, she'll just be cruising along and boop, another little baby will start climbing up her body hair and going into her pouch. Ish. A lot of them don't make it. It's pretty dodgy.
How do
She
they
might be
like
swimming
swim?
and one of them comes out and just swims away and like, lost another baby.
Oh,
It is wild. It is nutty. And imagine how trippy it is that whoever discovered this noticed that there's a placental version of everything marsupial, kind of.
Is that what that is?
And Charles Darwin started talking about natural selection around this time, and this geologist started talking about uniformitarianism, the idea that geological processes are slow and consistent, like tectonic plate movement and erosion and stuff.
Why did that happen?
Why did which part of this happen?
Why is there a split between marsupials and placental?
So now we can put this all together because we've built this giant body of knowledge, but imagine when this was just tumbling around in the public and rich guys would have dinner parties and they would ask these questions and sit around and drink and smoke cigars and trade slaves.
No, but I'm actually curious, like why did something evolve to like have that happen?
Lucky for you, I can answer this. So this guy, Charles Lyell, noticed that the tectonic plates were moving a teeny little bit at a time. And so since then, we've built uniformitarianism and tectonic plate theory to understand that the tectonic plates are separate, moving every now and then they clump and then they separate. This was called Pangea. How many of you have heard of Pangea? So during the Pangea-Gondwana land split, all the mammals were marsupial mammals. That's marsupial mammals or mammals 1.0. So all mammals were marsupial. They would fall out of their moms as a grain of rice. And some mammal had a wacky mutation where it got stuck or something. And that mammal did better than the marsupial ones because every sexual event led to a successful childbirth of a mammal that comes out at a bigger size. So humans are kind of unique among the mammals. Keep in mind that most mammals drop a fully capable offspring that runs away to do its own thing. Like when a horse gives birth, it goes, and it goes pop, and then that thing falls on the ground and goes, and then it starts running. I've seen a giraffe come out of a giraffe, and when the fetus hit the deck head first, by the way, on concrete, it almost died. It was like, I could hear the knock from like, I don't know, 120 feet away, I could hear the knock. And we're all like, oh, that guy's dead. And then the little baby giraffe goes, and then like, it got up and like walked outside. And we're like, I guess that's a giraffe now. Turns out that being a placental mammal kind of wins. So there goes Australia splitting off with all of its loser 1.0 mammals, and then 2.0 mammals evolve here, dominate all the marsupials. All the marsupials get out-competed. It's called competitive exclusion. Number 12, the idea that when a good idea comes up, it'll outcompete the loser idea. So one species will outcompete the other one, exclude them, like kick them out. Competitive exclusion principle. Now we know that the placental mammal 2.0 outcompeted all the marsupial mammal 1.0, with one exception. Does anybody know the only native marsupial that's coincidentally one of the world's most widely distributed mammals? There's one marsupial mammal amongst us.
Squirrel.
No.
Possum.
Yes. The opossum. By the way, it's the only word in the English language that has two recognized, it's the only proper noun in the English language that has two recognized spellings. Possum and opossum. But yeah. Australia broke off with like flip phones before the smartphone evolved. And so Australia has a whole ecosystem of flip phones. And everybody else is like using predictive text and they're like T9 texting.
We don't know what that means.
You don't know what T9 texting is? On flip phones, like the 2 is an A, a B, or a C.
Oh, so you have to
So
do
you
like
press
two,
2 for C.
Yeah.
That's called T9. Yeah. Oh, I know, right? God. Yeah.
I just got the
Hey, so I'm trying to grow a beard like these geezers from back in the day because I'm so excited about these moments. Like, you know who had one of these? Charles Darwin. That's who. You know who else did? Charles Lyell. My boy is named after him, and so is my dog. My boy's middle name is Lyle, and my dog's name is Charlie. Yeah. Yes, Diego.
Do you know like humans are the ones who ended up with like useless babies?
Yeah, we do. So trends in evolution sometimes have trade-offs. And so bigger brains have benefits, but of course it's tough to pass that big brain through that horribly challenging birth canal. So some species, if they have a really big brain, are born incomplete because they would be too big to come out done. Right? So there's this trade-off with walking and the human pelvis and body mass and being able to outrun a lion and these big brains. So we give birth to a 3/4 done fetus, and then it spends the 4th trimester carried around by the mom. It shouldn't be out. Their brains aren't finished yet, so they get confused. They have what's called synesthesia. It's like when humans take acid. So they feel sounds and they like hear colors and stuff. And so they just cry spontaneously because you'll make a sound and it'll look really gnarly for them. 4th trimester.
So is that why you don't remember it?
Wait, what?
So is that why you don't remember it?
Why we don't remember that early time in our life?
Or is it just because it's not developed enough? Like,
Well, you may be onto something there. But also memory is a really flawed system. But yeah, those first 3 months are pretty complex for the growing human.
So the first 3 months is the fourth trimester.
Fourth trimester, yeah. It's a trimester, 9 months, broken into thirds, 3 months, but there's the first 3 months of being outside the mom is the fourth trimester.
And what do we call the years after that?
Anyway,
Well, we can't do anything on our
look at all the
own.
stuff that you guys learned in this class.
You should work lessons.
Just not apes. So look, there's a couple of interesting things that happen in evolution. One thing that happens in evolution that is interesting is adaptive radiation. This is a study, this is a vocab term, where a species will adapt to new environments as it radiates into them. Please look up, please look up, please look up. By radiation, we mean like a bullseye that radiates outward. So a single species might radiate to 2 separate islands. One is wet, one is dry. So the ones with the wet genes have more babies and the ones with the dry genes have more babies. Then when they spread out, the wet ones do better at eating nectar or at chewing leaves, while the dry ones do better at eating insects or eating cactus. And so they'll kind of diverge into those roles. And adaptive radiation raises some interesting concepts. Please look up. From an ancestral species, you might diverge, this is called divergent evolution, you might diverge into very different niches. Like this is dry and this is wet little bird jobs. We call those niches, where a niche is a way to make a living. Way to make a living. So if you can describe how a species does its thing, that is its niche. So a great white shark is aquatic in salt water. It's a chase predator. It's I don't know. It has sharp teeth, so it cuts open its fish. The niche is however it does its job.
It's like a very broad term.
Yeah, niche is the description of how that species fits into its ecosystem. And you can imagine that whenever a new idea pops up, it opens up a whole bunch of niches. So imagine this, please. There was some fish. It was called fish number 1. That had a lot of variability in the flipper length. So there was some short flippers and some long flippers. And some fish with the long flippers was being chased by a predator and just slapped its way up on land. Got away from the predator, went back into the water because it's a fish, swimming around. Here comes another predator, and it runs away and just flaps its way up on land. And by escaping predators, the long flippers had a lot of babies, and so the gene for long flippers became more common, and that original short-finned ones were probably left. So these were the boring old species, but over time this gives rise to long flippered fish that can flap around on land. And some of them have oily gills, and some of them have gills trapped on the inside, and over time you could imagine that this might lead to amphibians. We don't know the exact details of every step in that progress, but there's probably some linearity where existing variation, you should know this in your notes from the last time we talked about evolution, existing variation in an environment with competition will have some individuals having more babies and those genes become more common. Like if it was good for you to be tall, then you might survive more and you might have more babies that have the tall gene. Whatever ugly teenager genes you've got, if those were helpful, they become more common. Yeah.
Have like humans gone through any like evolutionary changes like throughout like recorded history?
Well, we understand evolution to be a longer process than our record of history. It's important to point out that evolution is just reproductive success, whichever genes become more common. But if you look around at humanity, we define success differently. Right? So like if you're like Western successful, you probably don't have a lot of kids, and so your genes are going away. So genetic fitness is kind of irrelevant to what we call success. Humans are becoming more Southeast Asian because that is the region of the world that has the highest fertility right now. And so a bigger percentage of our genotype is whatever's happening in Southeast Asia genetically. And so who knows what that is. It's sort of decoupled from physical fitness, probably, because society has weird rules about who gets to eat and who doesn't, and who gets to have babies and who doesn't. So we're evolving, but kind of differently now. It's not really natural selection. It's a weird type of artificial selection. Yeah?
Yeah, but then like the Homo sapiens was us like to the Neanderthals, so would not also be like an evolution over?
Como?
Like, was there like the Neanderthals and the Homo sapiens and then like Neanderthals ceased to exist?
Yeah, so it's kind of mysterious how Neanderthal and Homo sapiens cross-pollinated a little bit, but it looks like they had a lot of backbreeding. So Homo sapiens showed up and we're like, whoa, Neanderthals, suck it. And I think that they kind of like did it. Because all of us that are Homo sapiens have a surprising amount of Neanderthal genes. Some of us more than others. You can always tell by the eyebrow thing, that's actually a thing. So like Neanderthal genetics, but we all have some Neanderthal genes. Anyway. I'm almost out of time. Hold on. Bear with me for a sec. I need you to realize that when a new niche pops up, like all of a sudden, now there's some fish that can flap around on the sand for a while. As soon as they can like stay on land, then a whole bunch of niches are going to open up on land. Somebody can go underground on land, and somebody can go in the trees on land, and somebody can hide in the leaves on land, and somebody can be really big and loud like us on land. And so you get these patterns of one niche opening up many new niches, and then a new idea will pop up that gives rise to many new niches. And there's this other really interesting pattern too. Some niches are really broad, like not very picky. Imagine an alligator. Its niche is swamp reptile, period. Because they can basically eat anything. Any swamp. Any temperature.
So those with the easiest niches are invasive, or tend to be more invasive?
Any water quality.
Those are generalists.
These are, first of all, called generalist. You'll need this vocab. They're generalists. They have broad niches, and they are really good at invading. Because they show up in a new swamp and they're like, my swamp. And they go to some other swamp and they go, I can do this too. Generalists are very good at invading. Yeah, invasive species tend to be generalists. And you know what's interesting about generalists? They're not very good at one thing, but they stick around. It's like Jiffy Lube. Jiffy Lube's not like really good on Ferraris or really good at Toyota, but they're like, nah, you got a problem, I fix. Not super picky. There's a different thing that happens in evolution called specialization. And specialists are the opposite. They're super picky. It's called a narrow niche. They'll be picky about nutrients, temperature, location, timing, elevation, diet, seasons. They're really picky, super picky. Believe it. And as long as the environment is stable, they can pull it off. Like, if you got a lot of people with Ferraris around, you could be a Ferrari specialist. And you're going to outcompete Jiffy Lube every day of the week when there's Ferraris around. But if you only work on Ferraris, you've got kind of a narrow market. You better hope that those Ferraris stay in town. Does that make sense to everybody? Like, if you have a Ferrari, where are you going to take it? The specialist or the generalist? Because you know that he's going to be better at it because that's what he does. The flip side is he's really counting on you to stick around. So, stability favors specialists, while change favors generalists. We understand so much about the world today. We can look at a weird dinosaur that looks just like a dolphin, except it evolved from a lizard. Dolphins evolved from something like a hippo. And from two really different starting points, lizard and hippo, over 90 million years of time frame, they both end up being so similar. Look at their eyes, look at their teeth, look at their beak, look at their fin pattern. This is a vocab term called convergent evolution, number 16. This is a great example. Where stuff which has a really different past ends up looking really similar. Why do they look so similar?
Similar climates and evolutionary processes.
Similar forces will shape them to have similar adaptations. These two dragonflies try to breed with each other, but their nuts and their bolts don't fit. One of these is from the United States, one of these is from Australia, and they look so similar that they believe that they are the same species, even though they are not the same species. It's like trying to have sex with a mannequin. Say what?
That fights back.
Yeah, right, that fights back. Yeah, that's true, yeah. Yeah, that gets frustrated. It's also trying, yeah. Bye, children.